The last type of trig equation that we're going to be working with is a trig equation that is a quadratic, but there's two different types of trig functions inside of it. Here I can see a cosine and I've got a sine. And when I run into the situation, I can't use quadratic formula or I can't use factoring in the way it's written. Because with the factoring in the quadratic formula, it is assuming that we've got the same variable all the way through. I might say, well, there are x's all the way through, and that is true, but that x is a part of a function. So I need to make sure the function is the same all the way through, that my cosines and sines and tangents and secants, it's one type all the way through. And the way that we're going to do this is we're going to replace the squared term with an appropriate Pythagorean identity that matches the middle term. So my middle term is sine, and I see a cosine squared. So which Pythagorean identity deals with sines and cosine squareds? And if you think back, it's going to be the cosine squared of x plus sine squared of x is equal to 1. And what I want to do is I want to replace cosine squared with this in terms of sine. So I'm going to solve this for cosine squared. So cosine squared is the same thing as 1 minus sine squared of x. Just moving that sine squared to the other side, and now I got the cosine value. I'm going to substitute this into my equation. So 2, and then the cosine squared of x is 1 minus sine squared of x plus 3 sine of x minus 3 is equal to 0. So now that I've done that substitution step, I've got sines all the way through. And with that, I can do simplification, quadratic formula, factoring, all the stuff that I've done in the past. So we'll distribute that 2 in. 2 minus 2 sine squared of x plus 3 sine of x minus 3 equals 0. I can combine my like terms right there. So minus 2 sine squared of x plus 3 sine of x minus 1 is equal to 0. And now I'm to the point that I can factor. But since I've got this negative in front, it's a lot easier to factor if we've got a positive number. So let's just take this whole equation and multiply through by negative 1. Which then gives me 2 sine squared of x minus 3 sine of x plus 1 is equal to 0. Now I can do my factor by grouping that I'm used to, or I can say the factors of 2 and 1 that add up to negative 3. And the factors of 2 and 1 that add up to negative 3 are going to be a negative 2 and a negative 1. So with this right here, my factors will be negative 2, negative 1, add up to negative 3, multiply to a positive 2, which is what I wanted. So we'll replace that negative 3 sine of x with negative 2 sine of x and negative 1 sine of x. So 2 sine squared of x minus 2 sine of x minus 1 sine of x plus 1 is equal to 0. Those are the two factors that I substituted right there. Then I can do my factor by grouping. And from the first I can pull out a 2 sine of x. And I'm left with sine of x minus 1. The back I can pull out a minus 1. And I get a sine of x minus 1, because I need both of those quantities to be equal. Now I can set everything as being outside the parentheses as one factor, everything inside the parentheses as another factor. So 2 sine of x minus 1, and then sine of x minus 1 is equal to 0. And since we've got two factors being multiplied that are equal to 0, we'll set those up as two separate equations. So 2 sine of x minus 1 equals 0, and the sine of x minus 1 equals 0. And we'll solve. Add 1 to both sides, and then divide by 2. And then over here we'll add 1 to both sides. And since we've got our sine equation, we'll just take arcsine to both sides. So the sine and the arcsine will cancel out. And these two values are on the unit circle. Sine is going to be positive in the first and the second quadrant. And what are the angles that produce a y measurement, or a y coordinate of 1/2? And you can see the y coordinate of 1/2 is at pi over 6 and 5 pi over 6. And the arcsine of a positive 1 is going to be at pi over 2. If you run into the situation here where this does not factor down nicely, or this is not on the unit circle, you would then go to the calculator, set up your reference triangles, and do what you have done previously as you factored.